Welcome to Buildings and Beyond,
a podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
My guest this time is Richard Faesy, who is one of the principals and founders of Energy Futures Group in Vermont, EFG. They focus on energy efficiency and renewable energy more on the program side, more on utility programs and policy side. And they're really involved with a lot of kind of cutting edge program design all around the country, but mostly in the Northeast. And we talked about a growing trend that many people I'm sure are seeing of electrification. Trying to forego fossil fuels on site, don't have oil or gas or propane at a home, at a commercial building. Instead, use cleaner grid electricity or on-site renewables combined with newer and much better heat pump technologies. A lot of this is driven by carbon emissions. Utilities, states, many programs have mandates to reduce carbon dioxide emissions. And with cleaner grids, with more renewables, using really efficient heat pump technologies can make that a reality. So Richard and I talked about this quite a bit. In the interest of brevity, we're going to cut in when we're talking about one of the programs in Vermont they're working on called Zero Energy Now, retrofitting existing homes around the state, combining efficiency measures, heat pumps, and on-site PV to really get very close to zero energy.
Yeah, well,
what's the status of that?
So Zero Energy Now program was one that we were able to quickly design, gear up, roll out in a limited period of time because of there was a funding opportunity that came along, and I'm a member of the trade association of the home performance contractors in Vermont that we call the Building Performance Professionals Association, or BPPA. And BPPA is really the organization that represents the interests and promotes the home performance industry in Vermont. There was some funding that was available from Green Mountain Power, our largest utility here, and we went after it and won it to put in place and really to demonstrate that we can take existing older homes in Vermont and save 80 to 90% of their total energy use through those three elements: weatherization, heat pumps, and PV. There were a couple homes as well that incorporated some biomass, some wood, either pellet or wood stoves as well too, which we consider renewable. But we had some pretty impressive results in the really it was less than 1 year to get everything up and designed and recruit and train contractors. Open the door, roll it out, complete the projects. We got approval in February of 2016, and we had to have the projects done by the end of that year. So we really had sort of 9 or 10 months to get it all going, and we completed 22 projects that will save. We're in the process of doing the analysis and going back and looking at what they actually used now that we've got a couple winters under our belt. But based on the modeling, and we had trued the models up with actual fuel consumption, but we are looking at about 79% total energy savings on average for these homes. So that was
Is that site?
That's significant.
Site energy?
That's site energy. Yeah.
Okay.
Yeah. So if you look at source energy, there's some significant impacts there with saving that electricity at the source, but that would be customer site energy, and we actually are doing some analysis right now, going in and pulling the fuel records from these homes. The first one that we looked at, actually, they saved more than 90% of their total energy. These people were generally true believers. They wanted to get off fossil fuel, but they're the great customers to have. But these were this particular home that we just looked at is probably 20 years old, 25 years old. I forget exactly when it was built, but we did sort of a $10,000 weatherization job. So not building out walls and replacing windows, but really sort of basement, attic, air sealing, hitting the high points, and then put in a couple cold climate air source heat pumps and PV on the roof, and actually overloaded the PV on the roof because they wanted to also buy an electric car, which they have in the meantime. And so they've really sort of walked the walk in terms of getting off of fossil fuel, and so this is just one of 22 homes we did in the first year. In the second year, we did another 15. So we've got these 35 homes out there, existing Vermont homes that range from 150 years old to 20 years old, that are really saving a significant amount of fossil fuel through the electrification pathway.
And the total cost to get there, I think I saw somewhere in the 40s, thousands.
Yeah, on average, while we had some projects that were more, some that were less. On average, it was about $40,000 package to do these homes. So that would be, it's $8,000 or $10,000 for the weatherization work. And it would be about $10,000 again for the heat pumps, and then about $20,000 for the solar PV. And
all right,
that was, but the resulting savings, the dollar savings for looking at the oil, propane, electricity that they were using at the time was what ended up being about $3,000 a year savings. So we're fortunate enough in Vermont to have some good financing programs that are available, some low interest rate financing for these types of projects from a couple credit unions. And you looked at, while we weren't necessarily asking people to use any one particular source of funding for these. Some people would pull from their savings, but a number of them would use the heat saver loan, which is what this is called. The energy savings, the $3,000 a year energy savings, were in almost all cases more than what the annual loan payments would cost. So people, even though these are $40,000 packages, the savings would offset that cost.
Wow. Yeah. I mean, a lot of deep energy retrofits, the costs start at six figures to really, take old crappy walls and make them R40 and replace all the windows with triple pane windows, which is all good stuff, but very expensive. So this is a lower cost way to get close to zero. I wonder, have you guys looked at comfort in these homes? Is that part of the evaluation? That is part of the evaluation that we're going through now. We're actually earlier this week we were looking at the set of questions that we'd go back to the homeowners with. So we want to know exactly, how is their experience? What's their experience like living in these homes? Are they more comfortable? Because most all of them were homes that people had lived in before. Some of them they had recently bought them and wanted to do something about it. We've got a little video online that actually is one of the participants who's a young farmer, and they bought they bought an existing home. They'd been there for a while, and they wanted to sort of move off of fossil fuels. And so I don't know how many of these people. Most of these people probably have some experience before and after the weatherization work, but part of the evaluation will tease that out. Yeah, and that's I mean, I'll try not to get too far into the weeds, but heat pump technology has come a long ways, but I still see misapplications where the wrong system is installed in the wrong place and people are unhappy or uncomfortable with the results. So it's something you got to be careful of.
It does blow air around, so yeah, there are those potential comfort issues if you don't get it right, and so addressing the weatherization component is important. So we want to make sure that was part of any picture going forward. But that really what's enabled us to do what we're doing here is the fact. I mean, it's a couple things. We've certainly learned how to weatherize buildings, and we've become more adept and efficient at doing that over the last number of decades. But the heat pump technology, as you alluded to earlier, has really enabled us to apply electric heat in cold climates. We've got, and I personally have a couple of heat pumps at home, and see them operating down to 20 below zero. Actually, we have them in our office as well too. And last winter we had a string of days here that hit 20 below, and they continue to chug along. They're not as efficient certainly as they are at warmer temperatures, but they do work, and it's not electric resistance heat even. They're not getting the best COPs, but it's certainly better than a COP of 1. So anyhow, so the heat pump technology has really enabled us to do this, and the cost of solar has come down, and we've historically had some really beneficial net metering rules and incentives here. Those are changing a little bit as the market's maturing, but the price of solar is really competitive with electricity. So having technology that works in our climate and that is affordable allows us to package these elements together.
And you mentioned your office. Your office is an almost net zero energy, all electric, new construction commercial building. Yes?
It is. It's actually half of it is a 150-year-old farmhouse that we did a deep energy retrofit on that. And then we doubled the square footage, and that's new construction. But we've got our 60 ceiling, our 40 walls, triple glazed windows, good insulation around the slab in one part of it, and the basement in the other, and really passive house tightness levels of air tightness with heat recovery ventilation. But and we've got only heat pumps in here to provide heating and cooling. So we're 100% electric. We snubbed the gas line that runs along out underneath the sidewalk out front, and
all right.
So we don't have to pay that monthly gas fee, and we needed to have electricity anyhow. And we had it's been almost at net zero. We're 500 kilowatt hours short, and we've got we've discovered what's going on, and we are taking measures to change that. And we expect we'll have excess electricity next year as a result of that.
Gotcha. Yeah, you're revamping the heat pump system, I think you mentioned.
Yeah, we are. We have discovered through extensive monitoring of our two multi-zone systems that they are a combination of them being oversized, and the fact that the multi-zone systems in a tight high performance building don't really. There's a challenge with it turning down. It basically doesn't turn down to meet the low loads of the building. So there's a lot of cycling on and off, and that's really driven the performance of the multi-zone systems down. We are replacing the two outdoor multi-zone compressors with 5 individual compressors to drive each of the 5 indoor heads, and which will allow us better control and the ability to turn each of those down to much lower levels. So we're expecting to to see a significant bump up in our COP, annual COP, and the performance of the system over the next year. In fact, I just this morning scheduled the swap out happening beginning of February, so we will be monitoring these for the rest of the winter after they go in on February 6th and 7th. And so it will be interesting to see the comparison sort of before and after on a per degree day basis. But our expectation and the anecdotal experience from others is that having the one-to-one units is going to improve the performance of what we see here.
And I think people are people like you are letting other people learn. I mean, you're learning the hard way,
right?
And manufacturers now, heat pump manufacturers now are acknowledging that these multi-zone, multi-split heat pumps are probably not appropriate for very low load buildings. It all depends on the application, but
yeah. I believe that the manufacturer we worked with, I don't know whether we name names here or not, but they I know that they've been aware of these issues for a while, and it was really encouraging to see just last week coming out with a national bulletin going to all their contractors, basically acknowledges this issue and provides some guidance, based on our experience and others about how to design, select, install, and control these heat pump systems in low load buildings. So that was really encouraging to see that response and acknowledgement that this is an issue and providing some solutions for others going forward. So yeah, we feel a little bit like the guinea pig, but that's okay. I mean, we're in it for trying to figure out how this works so we can let others benefit from that and not make the same mistakes going forward.
Excellent. So this kind of new construction or dramatic gut rehab, I guess, in the case of your office building, that's something that I personally see that, going all electric in new construction, very efficient, is almost a no-brainer in a lot of building types. For a residential or some commercial, is that if you can get, in my experience, if you can get the loads really low, then heat pump technologies are much easier to implement. And
definitely.
Do you see that trend in programs or in, I'm not seeing it as much as I would like, I think.
Well, one of the projects that we've been working on recently too is helping the state of Vermont update the residential building energy standards, basically the statewide energy code on the residential side and also the commercial building energy standards, so RBs and CBs. But our energy codes are being updated. They'll go into effect a year from now. After the sort of transition period over 2019 and training and we're about to go through the rulemaking process, and then we'll be training and some more support materials that follow that with the implementation date January of 2020. But we've had a lot of conversation and stakeholder group, advisory group meeting and discussion about where electrification fits into that. And there's some tensions going on there, but generally the industry, it's interesting, the industry sees this exactly as you do, Rob. Sort of the leading builders and developers and actually some of our affordable housing entities here who are looking at reducing operating costs for their tenants' buildings. As we bring the loads down, there's a great match with heat pumps. It's a technology that works well, and it meets our state goals of 90% renewable energy by 2050 is sort of the overriding goal that Vermont's striving for. But the tension that I mentioned is that at the same time we have the state regulators and those that are overseeing state policy concerned about winter peak issues, and so how do we how do we mitigate this driving, electric interest and drive towards electrification with this issue I mentioned before about needing to make sure that we have enough electric supply to meet shift our electric peaks from, we're sort of balanced in Vermont, at least between summer and winter. We had historically been a winter peaking system, but we got most everybody off electric heat, and now that's sort of coming around again. And how do we address that? What are the appropriate resources, renewable resources, to meet those needs? So that's sort of the challenge and the tension that's going on. Almost in some cases, almost in different sides of the same organization, or that are out there trying to do electric planning and advocacy for getting us towards renewables at the same time.
That's tricky. No easy answers, I don't think, on that one.
No. Although, so we some of the solutions could be around utility scale storage and or distributed storage as well. So as we see the price of batteries coming down, which it has rapidly, are there opportunities for us to have container-sized batteries that store renewably generated electricity from PV or wind during the day? Actually, wind is a different issue because a lot of times it blows, it'll blow at night as well too. But
right.
At least we've got a lot of PV resources that don't meet that nighttime heating demand, and could storage be a part of that solution? I'd like to think that it is, and we need to get our incentives right. It's our rates designed right, so that we encourage that to happen, and that's gonna help move things in that direction, and try to head off the peak issues. Avoid turning on those dirty peaker plants at night when it's coldest out, and people's heat pumps and electric heat are all turning on.
Interesting. So looking ahead, is that one of the things you think we'll see, you hope we'll see? It's just evolving rate design to make all aspects of this more practical and more palatable?
Yeah, I think like a lot of things, it just the regulation to some extent sort of trails behind the innovators and the trends in the market. The market team tends to respond quicker than the policy and the regulatory environment does. And I know there's a lot of conversation, at least here, and I know elsewhere as well, at least in the Northeast in the region, about storage as we the sort of overriding goals that most of the northeastern states have is some large percentage of the electric grid being renewable going forward, and so how do we get there and meet those goals? And I think that there need to be some signals to the market that support those sort of higher level policies. And a lot of that is going to be through rates and providing incentives to just the reason that we have so much solar in certain states and not others is because of net metering and feed-in tariff incentives, and so there's policy and there was dollars that went along with that policy to drive those market decisions that the market then responds to those situations that are put into place. But on storage, I think it's the same case. If we were able to value the time of day in the rate design, and you had to you were basically incentivized for not using electricity during peak times, there would be some more incentives for putting storage in place, or for the market to come forward with storage solutions that would be cheaper, potentially. I mean, that would be, or you have incentives to store and use your own on-site electricity rather than relying on more expensive, dirtier electricity at peak times from the grid.
Yeah, and there's. I know some different utilities, some different regulators are playing with things like that, but it's not. Well, you're probably more familiar with them than I am, but there's definitely a move in that direction. A lot of places.
Yeah, there is. I mean, California's been thinking about this for a while. They're pretty aggressive in all of this, and they now have this time differentiated rate where at least every hour of the day, if not every 15 minutes of the day, is valued differently, and so that gets pretty complicated. But as we get more sophisticated with controls and having algorithms that drive decisions, if there are price signals that are built into rates that encourage people to use or not use electricity at different times of day, that can get translated into real dollars and encourages people to make decisions that hopefully align with what the policies are in moving us towards renewables. So that may be more than what we had wanted to focus on in terms of buildings and heat pumps, but really it's all connected, and it's really huge. Sort of it's really interesting to see this push and pull between individual choices at the consumer level with this technology that now works in our climates, and it's this cheaper PV opportunities, and how that impacts our public policy and our rate making and our grid infrastructure. It's all in flux and changing rapidly.
And it always will be.
Right. Yes.
So aside from storage, are there other technologies you're hoping for, you're wishing for, you see in the near future?
Well, as we try to figure out where heat pumps fit into the building space, as we've got these really lofty goals in our northeastern states around decarbonization and electrification, and weaning us off of fossil fuels. I mean, there's a tremendous amount of work to be done in the transportation sector, but we're really focusing on the building sector here. We've got a lot of buildings in the Northeast that burn delivered fuels, fuel oil, propane. And if we can displace that with heat pumps, there'll be some significant savings there too. But we have yet to really figure out how to best integrate the heat pumps and the existing heating plants that are in our buildings, furnaces and boilers. And there's some mixed messaging going out there about just run these things down to certain temperatures, run the heat pump down to 25 degrees, then turn on your heating system, or just run them during the shoulder seasons and run your traditional heating system the rest of the time. And then others saying, no, just set them and forget them, but set your thermostat a little lower, and the central existing heating system will kick in to sort of fill in the gaps when the heat pumps aren't able to meet the load of the building. But we have yet to see sort of smart integrated controls that provide good economic outcomes for the consumer. People, on any given day, it might be above 25 degrees, then below 25 degrees. Are we expecting people to sort of turn their systems on and off? I don't think so. And as well, one size does not fit all. You know,
Right.
depending on whether you're buying propane at $3 or $4 a gallon. I saw it at more than $4 a gallon for small deliveries the other day. Actually, for me, because we don't use very much, and so I was just outraged. So anyhow, with expensive propane and oil, and relative to the electric rates, who's sort of optimizing? And at the same time, we've got differing efficiencies, different COPs of the heat pumps based on the outdoor air temperature. So it's going to cost it's going to cost more per BTU delivered at colder temperatures from a heat pump than it is at warmer temperatures. How does that delivered BTU, cost per delivered BTU, compare to cost per delivered BTU from your furnace or boiler? Well, we can't expect consumers to make those choices.
Right.
We need to figure out controls that sort of optimize which systems to run, and maybe prioritize the electric over the delivered fuels if there's some sort of factor or value for carbon impact that somebody wants to layer in as well too. But we need to have better, smarter controls that will help optimize the performance of our systems, especially as we have multiple heating and potentially cooling systems in our buildings, and so I think that's another area of opportunity that we really haven't figured out yet.
And maintain comfort, I would add.
And maintain comfort, and that's the bottom line. Well, I mean, that's one of the bottom lines
Right.
for consumers: comfort and cost. So how do we deliver that in a way that's simple and makes sense, and maybe it responds in real time to the cost of the fuels and the outdoor temperature, the efficiency of the system,
And grid signals that you
anyhow,
were
there's a lot
talking
of work
about
to be
before.
done. Right, yeah.
Yeah. All right. So, where can people find out more about you and some of these programs? We can link on our show notes page. Your website is
energyfuturesgroup.com.
All right.
It's a mouthful, but somebody already had efg.com reserved. So it's energyfuturesgroup.com. Otherwise you'll get to somewhere in Australia.
Oh, all right. And there's you mentioned a video. We'll link to a video of the showing some showcases of the Zero Energy Now.
Yeah, our website does have some links to some of our projects, all of our projects on there, and there's a page on the building. You can actually see our consumption in real time. Our eGauge monitor feeds the data up to the web, and so there's a link there. You can see how poorly it performs on a day like today, where the snow is covering our solar panels, yet our heat pumps are on. But then in the summertime, how much electricity kilowatt hours we're banking, waiting for the winter as we have no loads and a lot of sun. Anyhow,
Yeah, that's cool.
energyfuturesgroup.com.
Excellent. And we'll provide links to all that. Well, this is a lot, Richard. There's lots going on, but thank you very much for joining us.
Good. Well, I appreciate the conversation. We've all got a lot of work to do, and I think we still have a lot to learn.
Oh,
so
I'm with
it's an
you.
exciting time.
Yeah, awesome. Thank you.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.